Hello fellow problem solvers, so today we're going to be doing a problem from the Serbian Junior Balkan Math Olympiad Theme Selection Test 2018, problem number 4. This is a very cool game combinatorics problem that I suggest you try out for a minimum of 30 minutes, ideally an hour and a half, but not more than 2.5 hours. If on the other hand you'd like to go along with us, I suggest you play around with the problem for the next 15 minutes. So now, without further ado, let's begin. So the problem statement says we have a 2018 by 2018 board. The first player puts down blue coins, which we label as X's, and the second player puts down red coins, which we label as O's. And the goal of the first player is to have n X's in a row, where n is 4 or n is 5. The second player's objective is to stop the first player. So now let's play around for n equals 4. Let's try to form 4 X's if we're the first player. So how would you do this? Now this actually is a point, like if you haven't done this already, like played around, I invite you to do so right now. Play around with putting X's in the middle of the board and then figuring out what the second player can do and what the first player should do, and try to come up with some strategies. So after a couple of playing around, which I hope you did, what I figured out was that if I have 3 X's in a row and these two next to it are empty, then I, as the first player, will win no matter what the second player does. So now, if I have 2 X's like this, and these 3 are free, that means the second player needs to play either here, here, or here. Otherwise, they will lose. And now this seems like something that's worth playing around with. So what I would do now is I would actually try to see if you can come up with any sort of strategy, perhaps, if such strategy exists, for the first or second player. So now what I would be doing as the first player, okay, say I play X, say they play O below me. Okay, I'll skip 1 and play here with an X. Now they have to play an O somewhere here, say they played here. Then I'll play an X here, say they play the O here again. They must play it here. Now I play the X, say here, because now I have 2 of these. Like this is half done, but they have to play here, so now I have this. And now, is there anything we can do here? And the answer is, actually, yeah. If I play an X here, they need to play with an O here. I play another X, they need to play an O to stop me from winning. Now if I play an X here, they need to play an O somewhere here, and they do so. And then I play an X here. And now they need to stop me here, but I'll just play another X here, and I will win. Now, take 10 to 20 minutes and see if you can maybe generalize this. And the idea really is to, now for me, the only thing I can figure out is to really do this case by case. Say if they play here, like after I played here, they play here. And now my next move is this, playing here. And now they have, how many options? 1, 2, 3. Those are free cases. Then for my play here, they also have a 1, 2, 3 cases, and now I would just like write these out and find strategies for each and every one of those. So for example, if I do this and they play an O here, I would, can I win earlier actually? I'll play an X here, and now say they play an O here. Oh, I can play X, O, X, O, X, and they can't do anything and I win. So, okay, so there's maybe easier ways to win, maybe more forceful ways to win when we write this down. And I invite you to do just that right now, because the next thing that we'll be doing is moving on to part B. Here's part B. So here's my intuition for n equals 5. For n equals 5, my intuition is like once you play around with trying to actually come up with 5 in a row, you'll see that there's something that the second player can always do to stop you. So now the intuition is there some sort of matching strategy that the second player can use to always make sure that you do not have 5 in a row? And the way to come up with a matching strategy is to divide up the board into some pieces and say like, if A, B, B, so if the first player, if an X is played here, then the second player plays here. And now that would stop anything in a row. Now can we stop columns as well? And now let's say we do something like this, C, C, D, D, and then again we do A, like 2A2, B2, B2. And now this is a sort of a matching that we can apply across the board. And the question is, does this sort of matching stop the first player from getting 5 in a row? And the answer is yes, it does, because no matter like what 5 in a row they want, like if they're going, like they can't get 5 in the same, in the same column, because they would have to pass through, like we can call these, say, dominoes that are put like this. They'll pass one full of these types. So, but one of them will always be occupied by an O. And if they want to go this way, they will always pass one of these dominoes, which will also, one of them will be occupied by an O. And so the second player can win for n equals 5. The second player can stop the first player from ever getting 5 in a row. And now I invite you here to take 20 minutes and try to write this down. Here's the write-up. So we assume the second player can win for A, and then there must be some forcing moves. And we say this is the move 1. If we have this sort of thing, then the second player must play on one of the empty squares. And now we move on to the second thing, which is, so now we formalize our idea, our intuition, and we say like the first player will play on the square 50-50, or the 50th row, 50th column. We divide them into these 4 quadrants, and we say that assume the second player, if the second player plays on QI or QI intersection QI plus 1, so something like this here, then we will play on the QI plus 2 intersection QI plus 1 with Q5 is Q1, Q6 is Q2, and we will use less than 30 squares, so without loss of generality, we play on Q1 intersect Q4s on the square 50 and 52. So now we move on to our casework on the next page. So we describe what we're going to be doing. Then we play here, then we here, then here, then here. And now we look at 2 cases. The first case is when second plays on this point right here, 49, 52. Then we do a sequence of moves, which really forces this sort of thing. Like we have x's, zeros, we have an x somewhere, something we have here. We have an x, 0, x, and we have something here. Then we play an x, there's a 0, an x, there's a 0 up here. Now we play an x, we force him here. We play an x, we force him here, and then we win. So then this wins. And now we move on to the second case, which we solve like this. We say that we play here, and then what will happen, the first then needs to go here, then we play here, and the first needs to cover the other, either 47 or 51, 52, and then we play here in the middle, which we know is free, and we win because both of these aren't occupied at the same time, so we win. And now we move on to part B. So we define for part B how the second player will play, and we do this mathematically. Like we can do this quite easily mathematically once you figure out a pattern that, like this, 4 times 4 thing just repeats, then you know like mod 4 is what matters, and then you describe this, and now you prove that the first player will never get 5 in a row, and you do this by, boom, we say that now for all xy, xy plus 1, xy plus 4, there exists an I such that this is one of 1, 3, 0, 2, 3, 0, 3, 1, 2, 0, 1, 2 modulo 4. And so the second played on one of these two, x and y plus I, or x and y plus I plus 1, or respectively, like the similar way for these same, column, we have that there exists an I such that a similar thing holds respectively for the column. And so we know the second played one of this one, x plus I and y, or x plus I plus 1 and y. This solves this challenging problem, and as always, thanks for problem solving.